To the water and water pollution, basically a lot of it's review. Why do we need water? What is interesting about water is it has multiple characteristics. One of them is the fact it goes from, we are in what's called a Goldilocks planet, which means we have all three states of water on our planet. It takes a long time to go from hot to cold. That's why by Malibu, temperature doesn't change as rapidly as what it does by San Bernardino. I would much prefer living in Malibu if I could afford it. And it's extremely good solvent. But at the same time, that makes it nasty. Because if we don't have enough water, we don't survive. There are animals out there, like the kangaroo rat, that never has to take a drink of water. It is adapted such that it gets all of its water from the food it drinks. Also, some of the properties of water include the fact that it erodes stuff. Because it dissolves things like rock and stuff like that, it will erode it. Also because things will dissolve in it, you can get chemical spills, everything from mercury to plant nutrients that will cause all kinds of problems. We have a limited amount of water. 326 million cubic miles seem like a lot, but it's not. 97% of our water is found in our icebergs, is found in the salt water. We can't drink that. Just under 3% is found in ice camps. We can't drink that. Less than, 0.00 something is available for us to drink. Looking at it another way, if I take this 55-gallon drum, less than 1 teaspoon of the water that could, if I fill this with water, less than 1 teaspoon is what would be equivalent to what is available to us on the planet Earth. Okay. Not a lot of the water is actually available. Most of it is undrinkable. Another way of looking at it is with a picture. We look at this thing right here. The planet Earth, of course, we always think that we've got huge amounts of water because it covers 70%. But if we look at the volume, that's the volume of all the water on the planet Earth. This little dot right here is all the fresh water. And this itsy bitsy one right there, that's the water we have available to drink that's in lakes, streams, aquifers, and the like. We don't have that much. We need to find better ways of controlling how much we use and finding other ways to find water available to us. Do I need to go through the water cycle? Please tell me no. Okay, we've gone through that before. You know what groundwater is, what the water cycle. Groundwater moves very, very slowly. In the United States, in China, worldwide, vast majority of water is not used for human consumption. Vast majority is used for agriculture. In the United States, next is used to cool off power plants, not just nuclear power plants, but coal and natural gas. You know that steam rising up behind it? That's from cooling the water that is used in there so they can be recycled again over and over again. 70% is used for agriculture, 23% for industry, and 7% is for domestic. On our planet, the average person to survive needs only 1.3 gallons per day. That's just to drink. If you want to drink, cook, bathe, and flush your toilet, you need 13 gallons a day. In the United States, we use 65 to 78 gallons of water per day per person. If you live in the Netherlands, it's only 27 gallons of water per day. And if you live in the country known as Gambia, you only have 1.2 gallons per day. Why? Because a lot of the water is polluted and they cannot use it, or it's very, very dry and they don't have that much available. Oftentimes also they have very, very strong necks because they have to walk 2 or 3 hours one way to get their water. The supplies are not available via pipe. And if you're looking at just the graph of it, it makes it even worse to think about. Okay, right there it says in 1990 we used 408,000 million gallons. That means nothing to me. It sounds like a lot. Where did most of the water go that you used in your home? Where? The toilet. You flushed it down. That's why I have a low flush toilet. Plus I have a sign I'm thinking about putting up in the bathrooms. If it's yellow, just be mellow. If it's brown, flush it down. Second is shower. 2 of the things in the restroom that use almost half of our water. This is what 1 million gallons means. If you take this classroom, the length from the front to the back, and make it into a cube, fill that up with water, that would be 1 million gallons. If we took 400,000 of those, that's how much the United States uses per day. That's a lot. If you have too little water, that's called either a drought, or it's called you have a dry climate, such as what's found at 30 degrees north and 30 degrees south, and 90 degrees north and south. Not much water there. A lot of countries do not have enough, and it's changing through times. If you notice, there are some countries that are under stress, some countries that you have no water at all. It has been documented that in the last 300 to 400 years, about 10 to 20% of all the battles we have fought was over water rights, because we're not sharing it. In fact, in California, there was basically a battle for water in California. Why? Because in the north, they have a lot. In the south, we don't have enough. And therefore, we tried stealing it a few years ago, and they tried separating from us. Okay, and I'll go through more of that in a minute. Now, we have built dams through time. Long time. 2,000 to 3,000 years we have been using canals and stuff like that. Egypt used canals to irrigate. Rome put aqueducts together to get water to Rome. And in the upper right, the far right, you can see some of the aqueducts from space. We've been using it. We started harnessing it back in the 1700s to grind grain. And the largest dam in the world is called Three Gorges. It's by Wuhan City, the site where the coronavirus started. But Three Gorges Dam displaced over 1 million people. It put in jeopardy a panda sanctuary because that much water was behind the dam. We have all kinds of earthen dams that, again, you can see from space. Everything from Hoover Dam to earthen dams. Some of the advantages, you can store water. You can produce electricity. You can use the water to irrigate. You can use the water to, play in. Some of the disadvantages, vast majority of the water you lose due to evaporation. Second of all, if there's enough of it, like behind the Hoover Dam or the Three Gorges, you can have earthquakes. What happens if you live downstream and it collapses? What are the 2 words you say? Damn it. You can use the water. Another disadvantage is all the water behind it gets rid of the people back there. And sometimes it changes the wildlife. For example, downstream from the Hoover Dam, there's not a lot of water. There used to be an estuary. Last 10 miles of the Colorado River was an estuary in Mexico. No longer the case. And behind the dam, instead of being warm-blooded fish, you've got carp that are cold-blooded, and catfish, some of them as big as your table, that they're going, hey, come visit me. So what we in LA did, without an aqueduct, we would not be on beyond 10,000, 20,000 people. But a guy by the name of Mulholland used the law and basically stole water from Northern California. That's why we named a road after him. If you look here, what he found out from the law is this place right here is called Owens Valley. And there's a lake up there. And the state law says that if you own property by a lake, you can take as much water as you want. So he went up, bought a small piece of land, and he started taking out water. And the city of LA started building an aqueduct. Now, the people up here, were they happy with that? No. And so this aqueduct, over the next 5-10 years, was dynamited multiple times. In fact, the National Guard had to come in and stop that from happening. Now, originally what they had is what is on the left, where it's basically concrete and it's got open water in it, but there's tons and tons of evaporation. Eventually they got to the point where they started piping it down covered. And you can see how big that is by the person standing next to it. One of the problems that happens is we overuse it. This is Mono Lake up by, I believe it's somewhere between Sequoia and Yosemite, that in 1941, they started diverting water from it for the LA aqueduct. Within 5-10 years, it looked like that. That's not where fish can go. That used to be 10-20 feet underwater. They're starting to put water back into it, but are fish going to be able to survive there? Probably not. Another sad story is this right here. This looks like Yosemite. It's part of Yosemite National Park. It is the valley that, according to John Muir, is more beautiful than Yosemite Valley. But after the 1906 earthquake, San Francisco demanded we need more water. So they built a dam that stretched basically across here. What happened to all the deer, all the bear, all the other things that lived upstream? They're not there anymore. They basically got flooded away, and it's not as pretty as what it used to be. So we started getting water down from that, and we decided, let's grow, let's get bigger. And so it became not enough. And San Diego went, we need water too. And so that's when the Hoover Dam was created, and they created what's called the Colorado River Aqueduct, where they started shipping it over from the Arizona, California line, and it basically took several years to have it go across, and some of it is used for agriculture, most of it is used for people. But there was a lawsuit in 1953 where Phoenix and Tucson said, hey, we used to get our water from the Colorado River. There's no water left for us. And so they had to stop diverting it all to California and allow some of it to go to Arizona. Another problem that occurred because of this is this thing right here. Right here you see the Hoover Dam, and right along here is where the aqueduct is. What happened is the techniques they were using were not always the best. And the aqueduct broke. And when it broke, it went down into what probably a couple thousand years ago was an inland sea. But there was no water in it anymore. But because the aqueduct broke, it filled with water. Well, there's no more water going into it. So what's happening to it? It's evaporating. And there have been times during the summer, if the wind is coming from that direction, you can smell that lake. Because what used to have fish in it no longer has fish in it. It's all dying. And so it smells really nasty coming that direction. Then we started going, oh, we have more water, we can get more people. And so we started what's called the California Aqueduct in the 1960s, where half was for irrigation, half was for domestic use. And it came from the Sacramento River and went the entire length of California, taking water from what used to be water for fish, where they could spawn. No longer happens, because you've got this great big huge pipe that can be the size of this house, of this room, as high as this room. How's a fish going to spawn right next to that without being sucked into it? Not going to happen. Dams are found worldwide. 39,000 of them in 1986. And how much water is behind them? There's enough water to cover all of California. The surface area of all those dams is enough surface area to cover all of California. That is no longer available for people to live or animals and plants and other things to live. Now, what are the negative impacts of dams? You lost species. You lose all kinds of different things, cultures, cities, towns. They're flooded. They're covered over. You can't go there anymore. I hate this picture. This is what was at one point in time was called Glen Canyon. I would have loved to have hiked through this. However, after 1966, that's what it looked like. It doesn't look quite as pretty. Groundwater, saltwater. We can use groundwater. Groundwater, we use tons of it. Vast majority of used for irrigation and drinking. And problem is, we'll get to it in a second. This is called the Ogallala. Ogallala is in middle part of the United States. It is from our last ice age. All the water in there that's left in there is from the last ice age, several tens of thousands of years ago. But it's drying up because we're using it faster than it can go back down into it. What is that called? That is called subsidence, where the water is coming out so fast that there is no more support for the land, and so the land starts sinking. What you see here, this top of the, what you see at the top of this pipe is the level of the land 40 years before this picture. Because of all the water being withdrawn, the land sank this much. This is what is being shown here, where it sinks so much that the buildings, the sidewalks, the roads are cracking. The other things that happen is because we are using so much of the water wants to come this way, go down into the ocean. It goes from the mountains down underneath to the oceans. Well, if we're withdrawing so much, we're sucking so much. It's not going to be just sucking this way. This way, we're going to be sucking it this way. And eventually what's going to happen is the salt water from the ocean is going to intrude on our drinking water. That is why if you go down to Hyperion Wastewater, which is right by LAX, there is a plant right close to it where they filter the water afterwards. So this water they purify at Hyperion, they filter it more. In fact, I have drank water from this location that 24 hours before had gone into Hyperion. And it was basically distilled water because they had filtered it so much. And what they do with the vast majority of it is put it down into these aquifers so that the ocean does not come up to the drinking wells. What San Diego and other Santa Barbara are doing is something called desalinization, where they're taking ocean water and they're not distilling it, but they're using what's called reverse osmosis. Reverse osmosis is where you have a filter and you push the water against the filter, and the only thing that can go through it is the water. The salt can't. Have any of you been on cruise lines? I was on it once, and the water tasted a little bit weird. Why? Because it was distilled water. They had these filters out in front of the boat, and as it traveled, the only thing that could get into the filter was the H2O. And that's what you were drinking on the ship. is basically desalinated water. We want to increase our efficiency. We want to not lose so much. Toilet flushing, huge amount of water goes there, is lost there. We want to change the way we irrigate. There are basically 3 ways that irrigation happens. One of them is we flood the area. The problem with that is 50 to 60% of the water evaporates. And when it evaporates, it leaves salt behind. Some goodly portion of the land up in the San Joaquin Valley is no longer usable. There's been so much salt left behind that nothing will grow up there anymore. Another way that they do it is by circular irrigation, and again, that is a little bit better, but still a goodly portion of it is going to be lost. The best way to do it is what we call drip irrigation, invented in Israel. And basically what you have is you have a hose that you run underneath ground. And this hose, about every inch or so, has a little hole in it. And so it has a little leak in this hole, and this hose is about 1 to 2 feet underground, and it goes around the roots. Oh, where does a tree get its water from? The roots. So it only gives the water where it's used by the roots. Or you could put it underneath. If you did it in this field, you'd only have to run the line along there. You wouldn't have to put that much water into it because you're only giving it to the roots, not to the entire atmosphere. We can improve the efficiency of our homes by not wasting as much water. But what happens if you get too much water? It's called a flood. And what you want to do to make sure that you don't die in a flood is you want to build a levee. You basically build a dam on either side of it so that the water does not flood you. The problem with that is they don't always work. And several years ago, there was a hurricane that hit New Orleans. And they had a levee along the side of the river. The problem is, down at the bottom, it broke. Well, did the water stay down there? No. It went and flooded the lower right-hand corner. They flooded most of New Orleans. Now, there are some laws associated with it. There's some riparian laws, which I talked about a few minutes ago, where if you live on the waterfront, you can take as much water as you want. We'll get into the laws that actually matter a little bit. Are there any questions before I go on? Okay, I'm going to go on and talk about water pollutants, contaminants. Again, we've talked about a lot of this already this week. What are some of the sources? It's called a point source. If I can point to a location that's where the pollution's coming from, that's a point source. If I cannot point like the sewage from agricultural areas, that's called non-point, where it seeps into the groundwater, it goes in, whatever, I can't tell where it comes from. Agriculture is the largest non-point source, period. Those terrible moo-moos. And what happens is it causes all kinds of nasties. Disease-causing agents directly oxygen-demanding, where it removes all the oxygen. We can have inorganics that can be toxins or acids. Nutrients, organic chemicals. I'll go through each one of these. So waterborne, we've seen this. Do you want me to go through great detail on all of this, like with this again? Probably not. Okay, but there are other things that do the same thing. Oxygen demand. There are certain things that require a lot of oxygen. For example, if you have a sewage treatment plant that's doing a really bad job, it's going to put sewage out into the river. Well, when it does, bacteria really like that. And so they start multiplying. And so the oxygen demand goes up. And when the biological oxygen demand goes up, the oxygen goes down. So what happens to the fish in that area? They die. Fortunately, it's a river. And therefore, after a while, you're going to be far enough to downstream that the pollutants are lower concentration. and it's going over rapids and such that it's going to start adding the oxygen back in, and so fish can survive again. Sometimes we have inorganic, like heavy metals, where it's going to cause acid or too basic or stuff like that, where you're going to have problems like we talked about in previous unit. We talked about sulfur dioxide and nitrogen oxides from electrical power plants where they burn fossil fuels. Sometimes it is buffered by limestone, where if you've got an area that has a lot of limestone, it will not have as much problem with acid lakes. Or if you find your lake behind your house or whatever is too acidic, you take a piece of limestone and throw it down in there, and it'll help buffer the pH, the acidity. What does it do on wildlife? At pH 5, fish eggs die. Below that, fish die. So there are some fish, acid lakes in the Northeast, that did not have fish. However, there are certain fish that are or aquatic animals that are more susceptible. For example, frogs can live down to pH 4. They don't care. Whereas if you're a clam, you can't go below pH 6. And so they have different preferences for what the pH is. Sometimes we add nutrients to the acidity, removes nutrients that we don't want. For example, it can remove aluminum. Aluminum from the soil, which is toxic to fish, which we don't want. Sometimes we add fertilizer to plants, either at home or on farms. And when we do, we always add too much. Well, if that's the case, it's going to, because of rains and stuff like that, it's going to go down into the ocean. And when that happens, you get something called eutrophication, where you've got so many nutrients that the algae is going to go nuts. Well, the algae going nuts die eventually. When they die, the bacteria removes all the oxygen, and it causes something called a dead zone. At the mouth of every major river in the world is a dead zone. The one in the mouth of the Mississippi is over 1,000 square miles where no fish can live. Sometimes we have organic chemicals, such as PCBs, DDTs, that are soluble in your fat. And therefore, when something is eaten, it may have a little bit in it, but every time you eat more of that, you get more of that chemical in you. And then when you're eaten, the next thing up the food chain gets more and more and more. That's called biological magnification. And so as you go farther and farther up the food chain, you get more and more in you until eventually the fat load is so much that if you lose any weight, you die. Sometimes we get sediment. That's called increased turbidity. Are we going to get any photosynthesis there? No. We can get radioactive materials. That's from Chernobyl. Instance of 2 people downstream from Chernobyl that obviously had birth defects, teratogens. Sometimes we can get heat. All heating plants, they heat up the water to cause the turbines to move. When that happens, they have to cool off that water before it works again. Where do they do that? Out in the lake. In Rochester, Minnesota, where you can get 5-6 feet of snow. There are Canadian geese there year-round, but they live on the lake right next to the power plant. Why? Because it never freezes over, because so much heat is pumped into that lake. Sometimes we can get invasive species called, like for example, the Asian carp, or in this case, the zebra mussels. What happened with the zebra mussels? They originated in basically the Soviet Union. And ships over there would come into the Great Lakes, and they would take on water. Why? So they would go up and down in the water for whatever purposes. And when they did that, these zebra mussels would go out into the water, and they started taking over. And it killed off lots of the other species that normally would have been there. We can get pollution in rivers and streams and lakes. where when the amount of oxygen goes down, you get what's called a sag curve. So the oxygen appears to sag right after you add material to it. But eventually that sag will go back to normal if it's a river or a stream. If it's a lake or the ocean, it's not going to. It's going to take a long time to get it back to normal. Eutrophication can happen because we're adding nutrients from too many places, and it starts growing, the algae starts growing, and it makes it not fun to swim. We can get ocean pollution from, an oil spill. We're going to be doing a couple labs with that in a couple weeks, where we're going to try to figure out one drop of oil. How much area does it spread over? Or how do we get rid of an oil spill? We can get that by either a tanker having a problem, we can have a problem by an oil rig, or anytime we have a rain in LA, there's an oil slick out in our bay. Why? Because all the oil that is dropped by your cars is washed out down into the streams that go into the lakes. When this happens, we're going to have problems with fish and things like that dying. Why? Because oil is not simple. There are certain parts that are going to evaporate, causing problems. There's certain ones that are going to stay as a slick on the top. Some of them are going to go down to the bottom, causing problems. This is Exxon Valdez that happened back in the 80s and 90s, and basically it caused a huge amount of problem, and it covered not just land, but a lot of organisms. What would you use to clean up that sea otter? Dawn soap. That's what they use for the water. They use Dawn soap to clean up the fish, the birds, and the animals that they can catch. This is the Exxon Valdez was huge, but compared to some of the ones that have been out there, it's nothing. We can also have sewage being spilled. We can have mercury being released. We saw the picture of this poor girl before. And her mother basically was drinking the mercury when she was pregnant with her, and it caused those birth defects. It was a teratogen. And again, anytime you do anything at home, make sure it does not go down into the drain, because that goes out into the ocean, including plastic. That can cause problems with the animals out there. Groundwater pollution is nasty because it takes so long to get out of it. When landfills are not properly made, in other words, the bottom of it is clay with plastic underneath, if that's not there, any nasty things like, old batteries or other things that you throw into the landfill are going to leak down into there and go into our groundwater that we want to drink. Drinking water quality. How do we get it so we want to drink it? We pump it in, we add chemicals so that anything that things combine with that chemical and float to the bottom. We remove that sludge and then we purify it with chlorine. When we get rid of sewage, we have two ways. One, some of you still may have septic tanks, where basically you flush the toilet, it goes underneath into the septic tank, it ferments, and then it goes out into your yard. That's why a lot of you have such green yards, because you fertilize it yourself. What happens with most of us, however, in Southern California is there's a sewer system. And with the sewer, there's basically three parts. Most of them in California and other places only use two of them. One of them is basically, it's screening, where we get rid of the chunks. Second part is we take those chunks and we break them down. Now at Hyperion Wastewater Treatment Plant, they take those chunks and add them to bacteria, and they produce enough methane to power the Hyperion Wastewater Treatment Plant, all the electrical parts of it. Now, some of the water legislation you need to know, you only need to know 1 and 4, the Clean Water Act and the Safe Drinking Water Act. We used to need to know all of those. Fortunately, you no longer need to know those. Any questions? Or is that enough?